Hey everyone, I hope you're doing well today. In this video, let's solve 20 different practice problems on one-step equations. One of the types of equations that we'll work on are in the form of x minus a is equal to b, where we're solving for x. In each of these types of equations, we'll add a to both sides to solve for x. Another type of equation we'll take a look at has the form of x plus a is equal to b. To solve these types of equations, we'll go ahead and subtract a from both sides of the equation to solve for x. Other equations we'll try are in the form of ax is equal to b or a times x is equal to b, and to solve these types of equations, we'll divide both sides by a to solve for x. And finally, the last type of equation we'll take a look at are in the form of x divided by a or x over a is equal to b. To solve each of these types of equations, we'll multiply both sides by a to solve for x. Not only will we practice solving some equations with whole numbers, but we'll also try some with integers or negative numbers and some rational numbers, or fractions and decimals. If you find this video helpful in any way and you want to support the channel, you can go ahead and do so by liking the video or even leaving just a comment. Let's get right into it. I encourage you to grab some paper, something to write with, and let's do some math together. In example 1, we have the equation y minus 11 is equal to negative 5. To solve this, let's use the addition property of equality and add 11 to both sides of the equation. When we do that, notice how this positive 11 and negative 11 on the left side are going to combine to make 0 since they're opposites, so we can write y plus 0 on the left side, and that's going to be equal to, well, on the right side we have this negative 5 plus 11, and that's just equal to positive 6. Based on the identity property of addition, we don't really need to write this plus 0, so we can write our solution as y is equal to 6. There's our answer. For number 2, we have the equation negative 65 is equal to negative 5x, or negative 5 times x. To isolate x, we're going to have to go ahead and use the division property of equality and divide both sides by negative 5. On the left side, this negative 65 divided by negative 5 is going to equal positive 13, so we can go ahead and write that. And on the right side, when we take this negative 5x and divide that by negative 5, these negative 5s are going to cross cancel with each other to make 1s, and we can go ahead and write 1 times x on the right side of the equation. We don't really need to write this plus 1 anymore because of the identity property of multiplication, so we can say 13 is equal to x, or turn this around and say x equals 13. There's our answer. For number 3, we have 6w is equal to negative 64. So the 6 means 6 times w, and to get rid of that 6, we're going to use the division property of equality and divide both sides by 6. On the left side, this 6w over 6, the 6's are going to cross cancel, so the 6 and 6 just become 1 and 1, and we can just write 1 times w along the left side. On the right side, we have this negative 54, and we're dividing that into 6 equal pieces, so dividing that by 6, we know 9 times 6 is 54, so we can write negative 9 on the right side of the equation. By the identity property of multiplication, we don't need to write this 1, so instead of writing 1w equals negative 9, we can just write w equals negative 9. There's our answer. For number 4, we have c over 4 is equal to negative 5. This just means we're dividing c by 4, so to balance that out, let's multiply both sides by 4. On the left side, when we're multiplying this 4 by the c over 4, these 4's are going to cross cancel with each other and become 1's, so we're just going to have 1 times c on the left side of the equation. On the right side of the equation, we have this negative 5 times 4. 5 times 4 is 20, so negative 5 times 4 is going to be negative 20. We can drop the 1 because of the identity property of multiplication and say our solution is c equals negative 20. There's our answer. For number 5, we have negative 2/7 p is equal to 4. So p is being multiplied by this negative 2 over 7, so to get rid of it, we're going to go ahead and divide both sides by negative 2/7. By doing so, we're using the division property of equality. On the left side, this negative 2/7 p over this negative 2/7, well, those are going to cancel out with each other, so they're just going to become 1, and we're going to be left with 1 times p on the left side of the equation. On the right side of the equation, we're going to have to do a little bit of division with these fractions and take this 4 and divide that by negative 2/7. So let me go ahead and write that workout, and then we'll get rid of it in just a moment once we get our answer. So 4 as a fraction is 4 over 1, and we're dividing it by this negative 2/7. Now, when we divide fractions, keep in mind that we take our first fraction and leave it alone, we make our division sign a multiplication, and we reciprocate the second fraction. So we're going to write negative 7/2. Now, we can cross cancel the 4 and 2 to make 2 and 1, And when we multiply this, 2 times negative 7 on top, that's going to be negative 14. And on bottom, that's going to be a 1. This whole thing just simplifies down to negative 14. That's what the right side of the equation is simplified to. Knowing that 1 times p is equal to negative 14, then we can go ahead and say that p is equal to negative 14. There's our answer. For number 6, we have 9 is equal to negative 3/4 times k. So to get rid of this negative 3/4 that's being multiplied by k, or its coefficient, let's go ahead and divide both sides by negative 3/4. That's just using the division property of equality. The right side's a little bit easier, so I'm just going to go ahead and do that first, because when we have this negative 3/4 over the negative 3/4, those are going to just cross cancel and make a 1 and a 1. So on the right side of the equation, we're going to have 1 times k. On the left side of the equation, we have a little bit more work to do because we need to take 9 and divide that by negative 3/4. So let's go ahead and do that on this side. 9 as a fraction is going to be 9 over 1, and we're going to divide that by negative 3/4. Just like earlier, we're going to leave the 9 alone and write 9 over 1. Then we're going to multiply by the reciprocal of the second fraction, which is going to be negative 4/3. We can go ahead and cross cancel since we have common factors. That'll be a 3 and a 1. And going ahead and multiplying the tops together, 3 times negative 4 is going to be negative 12, and 1 times 1 on bottom is 1. So this simplifies down to negative 12. So we know that 1k is equal to negative 12. Let's go ahead and drop that 1 now, and we can conclude that k is equal to negative 12. There's our answer. For number 7, we have 13 is equal to e over negative 2, or e divided by negative 2. To get e alone, we're going to have to go ahead and use the multiplication property of equality and multiply both sides by negative 2. I'll start on the right side since it's a little bit easier to deal with, and when we take this negative 2 that's on the top and the bottom, they're going to cross cancel with each other to make 1s. So on the right side of the equation, we can simplify this down to saying we have 1 times e. On the left side of the equation, we have this negative 2 times 13. 2 times 13 is equal to 26, so negative 2 times 13 will equal negative 26. If we know 1 times e is equal to negative 26, we can drop this 1 and say that negative 26 is equal to e. Turning this around, we can just say e equals negative 26. There's our answer. For number 8, we have negative 8 is equal to negative 4/5 times f. So we have a coefficient of negative 4/5 here, and to get the f alone, we're going to have to find that by dividing both sides by negative 4/5 or using the division property of equality. On the right side of the equation, this is going to work out a little nicer, so I'll start there again. And what's going to happen here is this negative 4/5 and negative 4/5 will cancel out to make 1. So on the right side of the equation, we'll have 1 times the f. On the left side of the equation, let's go ahead and figure out what this negative 8 divided by negative 4/5 is. Doing that on the side, negative 8 as a fraction is negative 8 over 1, and when we divide that by negative 4/5, keep in mind that we need to reciprocate and multiply. Reciprocating the second fraction, of course, we'll have negative 8 over 1 multiplied by negative 5 over 4. Don't worry about where you put the negative as long as you put it on the top or the bottom for negative 5/4. Going ahead and cross-canceling this 8 and 4, we can make that a 2 and a 1, and then multiplying on top the negative 2 times negative 5, that's going to be positive 10, and 1 times 1 on bottom is 1, so we're going to have 10 over 1, or just 10. 1 times f is equal to 10. If 1 times the value of f is equal to 10, that means that 10 is equal to f, or turning it around, we can say f equals 10. There's our answer. For number 9, we have 187 is equal to negative 17h, or negative 17 times h. To solve for h, we're going to use the division property of equality and divide both sides by negative 17 to start. On the right side, this will work out nicely because this negative 17 over negative 17 will cancel out with each other to make 1, so we can go ahead on the right side of the equation and just write 1 times h. On the left side of the equation, dividing this 187 by negative 17, that's going to be, let's say, negative 11. 1 times h is just h, so we can just go ahead and drop that and say that negative 11 is equal to h, or h is equal to negative 11. There's our answer. For number 10, we have negative 3.2 plus m is equal to negative 8.6. So to solve for m, we're going to have to isolate it and get rid of this negative 3.2 that's on the same side of it. Now, we can use the addition property of equality and add a positive 3.2 to both sides of the equation so that we can isolate the m. By adding the opposite of negative 3.2, which is a positive 3.2, this is going to end up being 0. So we can write that 0 plus the m that's on the left side of the equation is equal to, and on the right side of the equation, let's just go ahead and figure out what this negative 8.6 plus 3.2 is equal to. So it's still going to be negative, but I believe it's going to be negative 5.4. Dropping the 0 by the identity property of addition, we can say that m is equal to negative 5.4. There's our solution. For number 11, we have 0.7x is equal to 5.6. So the 0.7 is a coefficient, it's being multiplied by x, and to get rid of it, to get 1, we're going to divide both sides by 0.7. On the left side, when we write 0.7x over 0.7, what should work out is that this 0.7 and 0.7 cancel out and make 1s. We're going to get 1 times x on the left side of the equation. On the right side of the equation, we have to figure out what this 5.6 divided by 0.7 is. So how many times does 0.7 go into 5.6? If you slide the decimal to the right for both of these numbers, we can also do that as well, or multiply them both by 10. So we'll have 7 going into 56, and that's going to be 8 times, so that means that 1 times x is equal to 8. It works out the same way here. Now let's go ahead and drop that 1 by the identity property and say that x is equal to 8. There's our answer. For number 12, we have r divided by 4.6 is equal to negative 2.5. So we need to solve for r, and since r is currently being divided by 4.6, we can solve this by multiplying both sides by 4.6. On the left side of this equation, by multiplying by 4.6, we should see that these 4.6's will cancel out with each other and just make 1s, so on the left side of the equation, we're left with 1 times r. On the right side of the equation, we just have to multiply decimals and see what this negative 2.5 times 4.6 is. I believe that's going to be equal to negative 11.5, so go ahead and write that on the right side. We can go ahead and drop this 1 by the identity property and conclude that the value of r is equal to negative 11.5. That'll be our answer. And there you have 12 different examples of solving one-step equations that have positive numbers, negative numbers, fractions, and decimals. I really hope you found this video helpful in understanding how to solve one-step equations better, and if you did, let me know in the comment section down below and consider giving the video a like. As always, keep up the great work, and I'll see you in the next one.